What would have happened to the Earth if the sun suddenly turned into a black hole? That was the most frequent question we've been asked. And if you are already imagining the Earth spiraling towards the black hole sun, being spaghettified, and other similar horrors, you are not the only one. Okay, let's imagine for a second that the sun did turn into a black hole. What would it be like for us? Well, the black hole sun will not be giving out any light or heat, so prepare for miserable existence in freezing cold and pitch black environment. You will not be able to see the moon and our neighbor planets on the permanently dark sky anymore, only stars. Our sun, the heart of our solar system, is a yellow dwarf star, a hot ball of glowing gases. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Though it seems huge to us, the sun isn't as large as other types of stars. Earth orbits the sun from a distance of about 93 million miles. At the equator, the sun spins once about every 25 days, but at its poles the sun rotates once on its axis every 35 Earth days. Many spacecraft constantly observe the sun, helping us keep an eye on space, whether that can affect satellites and astronauts. The sun's core is about 27 million degrees Fahrenheit or 15 million degrees Celsius. Little stars, like the sun, die in a different way. When these stars burn up all the hydrogen in their cores, they swell into red giants. Their cores contract while various outer layers form and continue to expand. At the end, stars leave behind a very dense core, a so-called white dwarf, surrounded by a shell of gas, a planetary nebula. White dwarfs are dead remnants. No nuclear fusion is happening in their interiors. Newborn white dwarfs are very hot. With time, these objects cool down and become black dwarfs. Black holes are about mass squeezed into a point of infinite density called singularity. The more massive object you squeeze, the larger its event horizon. The point of no return is, and the further away from a black hole a stable orbit of a planet would be. For the simplest case of a non-rotating black hole, the size of the event horizon is determined by its Schwarzschild radius. A small, solar mass black hole would have a Schwarzschild radius of about 3 kilometers. Therefore, any planet orbiting more than 3 kilometers away from the center of the solar system would be safe. Of course, you may argue that the sun does spin, and so will the black hole. And you will be absolutely right. But in that case, the event horizon will be even smaller. As for the living things on our planet, life on Earth, even though it will stay on its current orbit, will not be a picnic. As the temperature on Earth drops, the surface water will quickly freeze. Without sunlight, photosynthesis will cease in plants, and, consequently, plant-eating species will die out. Humans might be able to survive underground using geothermal energy for heating and to generate electricity. Don't fancy living underground. You will be surprised to hear that underground living becomes increasingly popular these days, even with no threat of the sun turning into a black hole. With science on our side, we might be able to survive living near the black hole sun. Maybe, for Earth to be completely safe from a supernova, we'd need to be at least 50 to 100 light years away. But the good news is that, if the sun were to explode tomorrow, the resulting shockwave wouldn't be strong enough to destroy the whole Earth. Only the side facing the sun would boil away instantly. The lucky other half would experience a rise in temperature that would be 15 times hotter than the sun's current surface temperature and permanent darkness. And without the sun's mass keeping us in orbit, Earth would likely start floating off into space while its remaining inhabitants desperately struggle to stay alive. There's a chance that our planet could lock into orbit around another star that might provide the same light and heat as our sun. But by the time that happened, we'd all be long gone. If we knew in advance the day that the sun would explode, then we could buy ourselves as many as 1,000 years of time, provided we had the resources to sustain ourselves for that long. Within 1,000 years, Earth's atmosphere would freeze and collapse, leaving anything left on the surface exposed to cosmic radiation and meteor impacts. But hopefully, by that point, we'd have found ourselves a new home. The good news is that if the sun were to explode, and it will eventually happen, it wouldn't happen overnight. When the sun does die, it will be a long, slow, arduous process taking place over billions of years. The light from the sun is what keeps our planet warm. Without it, the planets in the solar system will get very cold. This would make it harder for life to stay alive in the solar system. Humans might even build something to move the Earth. This would let the planet survive being eaten by the sun as a red giant. The sun will become a red giant and then a white dwarf over billions of years. This is a very long time. We cannot watch a star do all of this, but we can learn how stars are born and die by looking at the stars in our galaxy, the Milky Way. The Milky Way has stars of all ages, and over time astronomers have worked out which ones are young, old, or dead. By studying the old and dead stars, we can discover what will happen to our sun in the far, far future. Fortunately, there are 200 billion other stars in the Milky Way, most with planets of their own. Perhaps our descendants will have mastered near light speed travel. Even with current technology, however, interstellar travel is conceivable on the kind of timescales we're talking about. The fastest spacecraft built to date, Voyager 1, is racing away from the Sun at 38,027 miles per hour. At that speed, it would take 70,000 years to reach the nearest star. But future humans might build interstellar arcs, giant ships on which generations of travelers would live and die before delivering colonists to a new destination. Such star-hopping colonists could spread across our entire galaxy before Earth overheats, even assuming no advances in rocketry. 50 billion to 100 billion years from now, though, all of the raw material for new stars will be used up. The last generation of sun-like stars will burn out, and humans will need a new kind of place to live. It turns out that we have better options than yellow stars like our sun. The Milky Way is dotted with red dwarfs, cooler and dimmer than our sun but built to last.